Hello class, so this is the lesson 4.2, the first part on critical points and turning points. Critical points, I'm gonna write CP for short. Turning points, I'm gonna write TP. And also another concept called increasing, I'm gonna write I for short, and decreasing functions, I'm gonna write D for decreasing. So let's begin the lesson. I'm gonna be doing this in two parts, so I'm gonna section this video into parts about the same size. So first, let me explain to you all of these concepts. I know this sounds complicated, but you're gonna see that with the diagram, the concepts are actually quite straightforward. I'm gonna explain to you these two diagrams, these two functions here. Take a look at this function in white. It's the function f of x. Okay, it goes up, then it goes down, then it goes up again. And on diagram 2, we have this function f of x as well. And basically this function does this. It comes from way down. It's going up, and then it kind of like stays flat for a moment, and then it goes up again, right? So let's see what's happening here. First of all, let me tell you, I'm gonna start the other way around. I'm gonna start by explaining to you what increasing and decreasing functions mean. Basically, it's the following idea. I'm gonna basically tell you what it means by means of an example. I'm not gonna give you the precise definitions of this. I'm gonna tell you this. I want you to take a look at the function in white, just in this section from point A to point B, and take a look how it's growing up. As we move from left to right, we can see that the function goes up. So we say the following. We say that the function f is increasing over A to B. Over this interval from A to B, the function is increasing. It's quite easy to understand why, right? Then over the interval from B to C, the function is decreasing quite clearly. From the interval from C to D, the function is decreasing as well. And then right at the point D, the function starts increasing again. So basically this is happening. It's increasing, decreasing, and then increasing again. That's what the concept of increasing and decreasing functions mean. It's a very simple idea. Then I want you to pay attention closely to this point here, point B, and point D. If I ask you what happens, what is special about these points B over here and point D? Well, we can see that at those points, my function goes from increasing to decreasing, right? It goes from being all the way up to all the way down. It's like the peak in this case, right? And then over this point, the function goes from decreasing to increasing. This is like the very bottom of a valley. You see what I mean? So basically at those points, at this point here and this point here, the function changes direction from increasing to decreasing, or from decreasing to increasing. And we're gonna call those points, guys, we're gonna call them turning points, puntos de retorno, turning points, okay? And we can see that at those points, the slope of the tangent, remember all of these are tangents, tangent, and tangent to the function. At the turning points B and D, we can see that the slope of the tangent is 0, right? And since the derivative gives me the slope of the tangent, then the derivative at that point and at this point is gonna be 0. Then over here we have this tangent whose slope is positive. I'm writing MT for the slope of the tangent. And we can see that although we don't know the value of this slope, we don't know how inclined it is, we know that it must be positive, right? This slope is positive. And then the slope of this tangent is negative. That's what I'm writing here. And then in here, again, the slope of this particular tangent is positive. Okay. Now, what about this other diagram? We have something similar, although not the same. At point B, we have that the slope of this tangent is also horizontal or 0, right? The slope of the tangent equals f prime of b. That is the derivative evaluated in b, and that must be 0 because the slope is horizontal, right? But in this case, guys, we can see that this point doesn't mark the difference from going up to going down. Actually, at this point, the function behaves this way. Look, it's going up, so it's increasing, and then it kind of like I told you before, it slows down basically. It stays flat for a moment. It stations for a moment, and then it goes up again. So it goes from increasing. It stops for a moment, increasing, and then it increases again. You see? So we're gonna call this point a stationary point. Okay? So once again, this point here, it's called a turning point, because the function changes direction. This point here is called a stationary point. And all 3 points, this point here, and this point here, are going to be called by the general label of critical points, puntos críticos. So let me say that again one more time. This point here, and this point here, all 3 are critical points, because at those points, the slope of the tangent is horizontal. But only these 2 are called turning points, puntos de retorno, and this point here is called a stationary point, punto estacionario. So basically, I have those definitions in here. I want you to read them, pause the video, and read these definitions. I think I've written them very clearly, what a critical point is, what a turning point is. Pause the video and read them and understand what I'm talking about. And then we have these other notes. All turning points are critical points, but not all critical points are turning points. On diagram 2, like I said, point B is called a stationary point. Got it? And I'm gonna write SP for a stationary point. Now another, one more definition or label or name that you have to learn. Turning points that resemble peaks are also called local or relative maximums. So for example, if you have a turning point looking like this, like a peak, like the summit of a mountain, this is a turning point, right? Because the function changes from increasing to decreasing. And if your turning point resembles the peak of a mountain, we're gonna call it local or relative maximum. Máximo local o máximo relativo. And when the turning point resembles a trough or a valley, which is this case, it's the bottom of a pit, so to speak. Okay, this is also a turning point, right? This one here. And when this happens, we're gonna call it a local or relative minimum. So local or relative maximum or peak, so to speak. And this is a local or relative minimum or valley or bottom. See what I mean? Okay, now in the next part of the video, I'm gonna show you an example completely fleshed out. I'm gonna do this very slowly. This whole problem, I'm gonna give you a function, this one here, and we're gonna find all of these things. We're gonna find its critical points. We're gonna find its turning points, the local maximums and minimums. Remember, they're also called relative maximums and minimums. It's the same, local or relative. And we're gonna find the intervals where the function is increasing and decreasing. So let's go to that video.